Okay, here we go. Get your packets out. This is 2.1, real numbers. This is for Algebra 1. All right, I'm going to zoom in here. First thing we got to look at is set notation. Set notation is just a set of numbers that are in these goofy looking brackets that I'm really bad at drawing. So it's just these brackets, all right? So it's just going to have a group of numbers in there, like let's say 7, 14, 21. Okay, it doesn't really matter. It's just going to represent a set of numbers. That's all it is. All right. So we have natural numbers. So this is just a brief little history of numbers. I'm going to start with a set notation. Natural numbers were just numbers to represent the things that we needed to count, like goats or chickens, right? I have 2 goats. You have 3 chickens. So our natural numbers are just 1, 2, 3, 4, and so on. All right? That's all that is. So I'm going to end that. So that just means that continues on to infinity. And then whole numbers, pretty much the same thing, except it includes 0. So 0 is a pretty big discovery in math, is to represent the absence of having something. If you have 0 chickens, right? Or 0 goats, something like that. So pretty much the same as natural numbers. It just includes 0 as well. All right. All right, and then integers. Now, what about the person who owes you 2 chickens or owes you 2 goats, right? He's in debt, so we needed a way to represent a debt. So we needed to make negative numbers, all right? So this goes all the way back to negative infinity and then approaches 0, right? Like -3, -2, -1, and 0. And so integers aren't just negative numbers, they're just all whole numbers that also include negative numbers, if that's a better way to describe them. Okay? All right. So that should be pretty straightforward. Some students get a little confused with integers and think that they're only negative, but they're negative and positive whole numbers. Okay? All right, and then rational numbers. So a good way to think about rational numbers, or one way, is they can be expressed as fractions. So I'm actually going to type this out here because I got really bad handwriting. So rational numbers can be expressed as fractions. There we go. Boom. All right. So example, fraction. That can be a proper fraction where the numerator is smaller than the denominator, or it can be an improper fraction where the numerator is larger. Okay, we could also have a mixed number, 2.5. Okay, and also just whole numbers, right? Whole numbers can be expressed as fractions, right? The number 4 can also be written as 4/1. Okay, just a quick review of some kind of elementary stuff on that. So if rational numbers can be expressed as fractions, irrational numbers cannot. So irrational numbers cannot be expressed as fractions. Made that mistake again. There we go. All right. So pause the video if you need to. Make sure you get these definitions down. They will help you later. All right. For this section, so another couple ways to differentiate between rational numbers and irrational numbers. I'm going to switch over to a different view here because I want to show you guys my calculator. All right, so we have -1/8. Okay, so I want to show you guys on my calculator here. So I'll show you 2 ways. So one way to convert a fraction into a decimal is just to divide the top number by the bottom number, right? Divide the numerator by the denominator, okay? And so negative 1/8 converts to negative 0.125, okay? And so this stops at 5, right? So another kind of a definition or way you can differentiate rational numbers to irrational numbers is that they terminate or they end, right? It just stops at 5, okay? Where we have, I think we all know that pi, right? Pi is 3.14, yada, yada, yada. It goes on forever. I think everybody knows that pi never ends. So irrational numbers are non-terminating. Okay? And another distinction between rational and irrational numbers, if we take a look at 11 or 16 over 11, and I'll show you the other way to convert a fraction to a decimal. Because I wanted to show you guys this n over d key because you guys will be using it a lot throughout Algebra 1. This n over d key here is your fraction button. So we just type in the numerator and then we use our arrow keys here to go down to the denominator, type in 11, and we can press enter. And what that does is just reduces the fraction for you or simplifies this fraction. So it looks like 16/11 is as simplified as that fraction can be. And if you want to convert this fraction into a decimal, you just need to hit this double arrow key in the right hand corner. Okay, you hit that button and you're going to get the fraction equivalent, or the decimal equivalent, sorry. And so it looks like we got 1.454545. So that means this number here, this decimal part here, this 45 repeats. Okay, so that just keeps going, 4545. So rational numbers either terminate or they repeat. Okay, and just like with 3.14, that never ends and it never repeats, so it's non-repeating. Okay. All right, and we'll look at this last one here. We have the square root of 2. So again, get out the calculator. We need to find our square root symbol. And so our square root is the opposite of squaring something. This is my squaring button right here. So to access this green function, we need to hit the second key and then the square root button. Okay, we've got that. Punch 2 in, press enter. Okay, so that just means that this is in simplest radical form. So if we want the decimal equivalent, we hit this double arrow key in the bottom right hand corner and we get the decimal equivalent. So it looks like this is 1.412135562, but that doesn't end there. It's just all the room that the calculator contains. So this does not terminate and it does not repeat, so this would be an irrational number. Okay. All right, I'm going to switch back over to other view here. All right, and we'll just take a look at some of these examples here. So we're going to label the following. So number 5, is number 5 is 5 a whole number? Yeah. And if it's a whole number, it's also an integer, and it's definitely rational. Okay. And you can't be rational and irrational. Okay. All right, now we got 0.6. Is that a whole number? No, a whole number is like an actual number, like 1, 2, 3. This is 6/10, and so I could write that as a fraction, right? 6/10. So this is not whole, definitely not an integer, but it can be represented as a fraction, so it is rational. And you can't be rational and irrational, so it's definitely not irrational. All right, -24. Is it a whole number? It's not a whole number because whole numbers are only positive. And integers are negative and positive whole numbers. So this is an integer and it is rational. Okay, so we could definitely write negative 24 over 1. Right? That can be expressed as a fraction. Definitely can't be rational. Okay, is 9/7 a whole number? No, of course not. Is it an integer? No. But is it a fraction? Yeah, even though it's an improper fraction, it is a fraction. It is a fraction nonetheless, so it is rational. Okay. The square root of 11. So I can't show you guys my calculator again, but I'm going to go ahead and type this into my calculator. You should do the same. Remember, you hit that second key and then the square root button. And it should spit out the negative or the square root of 11 again. That just means it's in simplest radical form. I hit the double arrow key and I get 3.31662479, and it does not end there, so it is a non-terminating and non-repeating, so this would be irrational. And if it is irrational, it is definitely none of the other ones. Okay? All right, 2.823, and it looks like the 23 repeats because the line is over top. So that's definitely not whole, definitely not an integer. It is only rational because it is a repeating decimal. All right, and last one here. I mentioned this before. It's a mixed number, so it's a fraction. So it's definitely not whole. Whole number would just be 2, right, or something even like that. So it's not whole. It's not an integer. It is just rational. All right. Hopefully that makes sense. Why don't you guys give problems 1 through 12 a shot today? All right, and we'll see you in the next video.